Hello and welcome back to Professional Tutors, the British online school. We are a unique team of qualified and dedicated teachers here to help our students to reach their full potential. So in today's lesson, we're going to discuss about entropy and free energy. In this topic, we're going to look at the spontaneous changes, spontaneous chemical reactions. We're going to look at free enthalpy and entropy. We're going to also talk about second law of thermodynamics. We talk about change of state, and we also look at the conditions which need to be there for the reaction to be spontaneous. So we're going to look at what are spontaneous reactions and what are non-spontaneous reactions. Right, so we're going to talk about spontaneous changes. We're going to look at the reactions that takes place by themselves. They don't need any input of energy, so they can take place by themselves. Exothermic reactions, they are normally spontaneous. For example, fire, once the fire started, then it doesn't need any input, it just goes by itself. So spontaneous changes are the reactions, or spontaneous reactions are the reactions which can take place by itself without any input of energy. Now, most of the exothermic reactions, they are spontaneous because they generate their own energy and they can use that energy to keep them going. So most of the exothermic reactions, they are exothermic. Now, but there are lots of examples where the endothermic reactions, they are spontaneous as well. So there is a big question here. So one of the condition, when we talk about enthalpy, one of the condition is for the reaction to be spontaneous, delta H must be negative. That means the reaction must be exothermic for the reaction to be spontaneous. But the fact that there are lots of reactions, they are spontaneous, but they are endothermic. So that means there must be a different driving force. So enthalpy is not just the only condition for the reaction to be spontaneous. That means there must be something else which must be driving the endothermic reaction to spontaneity. There must be something else as well. And that driving force is what we're looking at, is the entropy. So let's see what's happening. So the other factors which are responsible for the reaction to be spontaneous are entropy and free energy. Free energy, what you call Gibbs free energy, and that is the combination of enthalpy and entropy. So when you combine the effect of enthalpy and effect of entropy, we'll get to an equation what you call Gibbs free energy. So entropy is a measure of disorderness of a system, and that is going to be 1 or 2 mark question in exam for sure. So when they ask questions on entropy, the very first question is going to be, what is entropy? So entropy is a measure of disorderness of a system. So we need to know the more the disorder, the greater the entropy. Now, if the system becomes more disordered, so more disorder means the value of entropy is going to be positive. Now, enthalpy is represented by delta H, and entropy is measured by a symbol delta S. Now, if in a chemical reaction, there's an increase in disorder, so the reactants and products, so products are more disordered than the reactants, delta S is going to be positive, and that is going to favor the reaction. That means that is a factor which will lead to spontaneity of the reaction. So if delta S is positive, the reaction is going to be spontaneous. For example, if we got ice, now if you leave the ice, it's going to melt by itself. It's a spontaneous physical reaction. It's a spontaneous reaction. So it doesn't need any input. You put the ice out there and it will melt by itself. So that means what? In ice, the water molecule, they are put together, right? They are not moving. Less disorder. When ice melts, it will go from more order to less order to more disorder, basically. So when the ice melts, the water molecules are now free to move. So they are in a state of more disorderness. So if the value of delta G is negative, that's going to be a spontaneous reaction. If the value of G is greater than 0, that means positive, that is going to be a non-spontaneous reaction, but it will be spontaneous in the reverse direction. And if delta G equals 0, that means the reaction or the system is in equilibrium. Now that's really important 1-mark multiple choice question, and they do ask that a lot in exam. So we have to memorize this. If delta G is less than 0, the reaction is going to be spontaneous. Delta G greater than 0, the reaction is going to be non-spontaneous, but it will be spontaneous in the backward direction or the reverse direction. If delta G equals 0, that means the system is in equilibrium. So that's going to be your 1 or 2-mark question. If you want to find out the enthalpy change, delta S, that's going to be the final value of entropy, S final, take away S initial. So beginning of the reaction, the entropy at the beginning of the reaction, and entropy at the completion of the reaction. Right, so that's our second law of thermodynamics, and that is based on entropy. And that states that entropy tends to a maximum. And that means all the chemical and physical reactions, they involve an overall increase in the entropy. So the reaction can only take place if there's an increase in the value of entropy. An example, that is why the solid melt, because in solid the entropy is less, in a liquid entropy is more. And that's why the liquid boils, because when the liquid boils, it goes from liquid to gases, and gases there's more disorderness. So gases has got higher entropy than liquids. And again, that's why the ionic solids, they dissolve in water, because when they're solid, entropy is less, and when they dissolve in water, the ions are free to move. So that will increase the entropy or the disorderness. If there are more moles or more molecules of gas in a reaction, entropy is always there. So if you go from 2 moles of gas to 3 moles of gases or a gas, there will be increase in entropy. And the temperature increase. So whenever there's a temperature increase, that will increase the vibration, that will increase the movement, because the molecules, they gain kinetic energy, and that will lead to increase in the value of entropy. And that is what we can see here. So entropy increases when solids melt. So in a solid, there is a regular arrangement of particles, so less entropy, more order. And when it melts, so it's a less regular arrangement. The molecules, they can move around. That means more disorder in liquids. So there's an increase in entropy when the substance go from solid state to a liquid state. And that's one of the reasons why the ice melts by itself. And again, when there's a change of state from liquids to gases, again, irregular arrangement, but there's some sort of order. But when the liquids boil, the molecules, they are free to move around. The random nature increase in disorderness. So entropy increases when the substance moves from liquid state to the gaseous state. The same thing here. So if the ionic substance or ionic solids, why do they dissolve in water? Because in solid state, there's a regular arrangement in the ionic crystal lattice, and when they dissolve in water, they are free to move around. So there'll be increase in disorderness. That means there'll be increase in the entropy. And when there's increase in gas molecules, when there's an increase in number of moles, so more moles means more collisions, more disorderness. So whenever we move from less moles of gases to more moles of gases, there's always increase in the value of entropy. And temperature increase is again, so at lower temperature, the molecules or the particles, they have got less energy. So they'll be, they move around a little bit, but when you increase the temperature, the particles or the molecules, they gain more kinetic energy, there'll be more disorderness, and that means the value of entropy increases with an increase in the temperature. This is the equation we need to know, and that equation is what's called Gibbs free energy, and that includes the effect of enthalpy on the spontaneity of the reaction, and also include the effect of entropy at constant temperature. That's your Gibbs free energy equation, and this equation relates free energy, enthalpy, and entropy together. So for a reversible reaction at equilibrium, the value of G is always 0. Now if delta G is 0, so if delta G is 0, so if you substitute the value of delta G equals 0 here, and if you can rearrange this equation, then we'll left with delta H equals T delta S. And if you rearrange this equation to make delta S as a subject, then we're left with delta S equals delta H over T. All right? This occurs during change of state, melting or boiling and sublimation, all this stuff. So that is what we are interested in. This is the equation when it comes to calculating the value of entropy. So if they give you the value of enthalpy, positive or negative, depending on whether the reaction is exothermic or endothermic, and if they give you the temperature, divide them both and you will get the value of entropy from there. All right, so that's going to be your 2-mark question in exam. So calculate the entropy change. They want us to find out the value of delta S. When water turns to steam at 100 degrees Celsius, so that's the temperature, and make sure you convert degrees Celsius into Kelvin before you plug the values in. They've given you the value of enthalpy, delta H is plus 44 kilojoules per mole. That means that's going to be an endothermic reaction. And we know that if we have to boil water, we have to give energy. So that means it's an endothermic reaction. To simply use this equation here, delta S equals delta H over T. Make sure you convert degrees Celsius into Kelvin, plug the values in the calculator, and here you get the answer. And what we need to know from here, if the value of delta S is positive, that means there's an increase in entropy. That means that reaction is favored. So entropy change value are much smaller than enthalpy change values. They tend to be in joules rather than kilojoules. That is your 1 mark question again. And that is going to be a trap always. When we're going to do delta G calculations, they will give you the values of delta S in joules, but the value of delta H would be in kilojoules. So we have to make the units agree when we do those calculations. So normally we measure entropy in joules, joules per Kelvin per mole. So value of enthalpy, entropy should be in joules rather than kilojoules. So enthalpy, kilojoules, entropy, joules. So when we do the calculation which involves this equation, we have to make the units agree. We have to convert entropy from joules to kilojoules first. Another thing which is important to know, if the value of delta S is positive, the reaction is going to be spontaneous. If the value of delta S is going to be negative, the reaction is going to be non-spontaneous. What we need to remember, for a reaction to be spontaneous, the value of delta G must be negative. So first of all, look at whether the reaction is exothermic or endothermic, whether there's an increase or decrease in entropy. If the value of entropy is positive, that means there's an increase in entropy, and look at the temperature. Now that is a guaranteed 1 mark multiple choice question in exam. If delta H is negative and delta S is positive, then the reaction or the delta G must be negative. If delta H is positive and delta S is negative, then delta G must be positive. So we need to memorize these conditions, and they're going to ask you that in exam. We're going to look at the examples in a minute. So in this case, they've given us, and they will give you that in exam. So if delta H is negative, so this value is going to be negative. And if delta S is 0, the whole of this, the value of this, T delta S is going to be 0. That means the overall value of delta G is going to be negative. That means the reaction is going to be spontaneous. That is important to know. In this case, they haven't given you a value, but we need to find out that in this reaction, whether there's an increase in entropy or decrease in entropy. So always remember, if there are more moles of gases in products than reactants, that means the value of delta S is always going to be positive. So more moles of gas on right hand side, then that means delta S is going to be positive. If there are less moles of gases, we're just talking about moles of gases. If there are less moles of gases on the right hand side, the value of delta S is going to be negative. Now, because we can see there are no moles of 0 moles of gases in on the left hand side, 1 mole of gas on the right hand side, that means delta S is positive. If that is positive, the whole value is going to be positive as well. So if delta H is positive, if that's an endothermic reaction, very endothermic reaction, for G to be negative, T delta S must be bigger than delta H. Now in this scenario, if we want delta G to be negative, we want this value bigger than this. And where's that going to happen? That's going to happen at very high temperature. So that means what? When, under what conditions this reaction is going to be spontaneous? So the reaction is going to be spontaneous at very high temperatures. Right, for this one, there are more moles of gases or more moles of gas on the right hand side. So delta S is going to be positive. In this case, there are more moles of gas on the left hand side. That means fewer moles of gases in the product. So the value of delta S is going to be negative. Here, it's going from solid to gases, increase in entropy. So delta S is going to be positive. And here we've got 1 mole of gas on the left hand side. And here, sorry, my mistake, they've got 9 moles of gases here. And here, we've got 6 moles here and 6 moles here. So 12 moles of gases on the right hand side and 9 moles of gases on the left hand side. So overall, there'll be an increase in entropy. So delta S is going to be positive. And here you got 1 mole of gas on the left hand side and 1 mole of gas on the right hand side. So there's no change in entropy. So value of delta S is going to be 0. Thanks for watching. If you find the information useful, please subscribe, share, and like the video.